about surfing the web with Tor. So it's going to be either introduction and then some hands-on exercises for getting started with it. Welcome.
Thanks. So I'm Georg. I'm from the Tor project actually, and today I'm speaking about surfing the web with Tor. My original plan was to have a part which is lecture-like, the first part, giving an introduction about Tor, what it is. Then the second part should be a hands-on session where people can try to download the Tor browser in a secret way and verify that it's really the Tor browser that they want to have and not some fake thing. And the third part is a Q&A session where people can ask all things about Tor they wanted to know. And so that is actually my plan. If it's people are interested in different things, then we can switch. That's not a problem for me. So first, who has heard about Tor? Oh, that's cool. Who's actually using the Tor browser? So you solved already the problem I'm going to be talking about today. That's cool too. Then another things of these housekeeping things. Who wants to have these hands-on sessions today with let's say with a Windows machine? Nobody, yeah, surprise. Who wants to have the session with a OS X machine? Oh, that's cool too. And who wants to have this session with a Linux machine? Oh, nice. That's good. We can concentrate on the Linux issues. So the Tor network is actually an overlay network to give you anonymity. What's the exact problem it's trying to solve? So let's suppose you have Alice and Bob and both want to communicate with each other. The issue that then you have these big red cloud here in the middle, which maybe wants to try to find out that Alice is trying to connect. It's communicate with Bob, and Bob is trying to communicate with Alice. So, and we don't want it. We don't want this. We want to provide Alice a means of communication with Bob that rules out intermediaries finding out that there is such a case of communication happening at all. I mean, this is even an issue if your queen cylinder here is trying to picture this. So it's even an issue if you have a secret channel with between Alice and Bob, let's say in TLS session. And it's still possible to find out that the communication between both is happening. So Tor is trying to solve this problem. And the solution Tor is providing is this. So Tor is trying to split up the information about the communication to different parties. So the network is consisting of several thousand relays, which are basically servers around the world, which are running the Tor software. And if Alice is trying to talk to Bob, then she's using the Tor software, the Tor client, and is basically making a connection via the Tor client to a first router, the entry router of the path through the Tor network, and then the entry router is sending the request further to a second router, and the second router is sending the request to the exit node, and this exit node then is actually making the request to Bob. And this goes back in the same way. And if Bob is sending a response, then it goes back to Alice via the path out and there. There's kind of heavy crypto between those links here, which is not in the picture. It doesn't matter for now. But this assures that the readers themselves are not able to look at the payload and know what's going on. So what is actually achieved in this model is that the exit node is only seeing, well, there's some party trying to talk to Bob. And then there's Bob trying to talk to the party, because Bob is sending responses or stuff back. And the middle node only knows, yeah, there's some traffic coming from the first node and the exit node, and the first node is only seeing, well, there's Alice. Alice is trying to talk to somebody, and she's getting responses from somebody. So there's no single point in the whole communication path that is knowing who's talking to whom. That's the basic idea. But then you have still issues, showing in the previous slide. What if an evil, if Eve is trying to listen at the same time, directly here in this path and there over there, meaning what if we have an evil person or an attacker who's trying to listen here and here? Then it's still possible to do some form of correlation. Like this attacker is seeing, aha, here are coming packets and simultaneously there are coming packets out. Maybe there's some kind of correlation. And this type of attack, the traffic correlation thing, is an attack Tor is not really prepared to solve, because Tor is a low latency and dynamic network. It means it is possible to serve the browser web with it, meaning there's no delay here or somewhere with the messages, or there's no reordering of the messages. Instead, Tor has the idea to make it hard for an adversary to watch both here and here by rotating the circuit and making it hard, choosing the same path again. So this is one of the benefits Tor is aiming at. There are different roles. Maybe we are going to see some of them in the course of the talk. So still, I mean, this the previous things solve the problem of the network level, right? The things you don't see here. But still, I mean, you maybe don't want to be so exposed, like here, when you're serving your website. Meaning there are still problems at the application level, which is Tor, the network software, is not dealing with. So to deal with these problems, the Tor browser basically got invented way back. And the Tor browser is obviously a kind of browser. It is a modified Firefox, actually. So we take the Firefox source code. We apply a bunch of patches on top of it. And this is our browser part we actually ship. The problem we were trying to solve is that without these patches, it's still possible to correlate browsing activity or track users across domains. There are various means out there, like cookies. They are probably the famous ones. Cookies or some cache tracking mechanisms. E-tags may have heard. You may have heard about these. Flash cookies and stuff. So we apply a bunch of these patches to mitigate these issues. And then there are things like fingerprinting, which came up in the recent years, where scripts on the website are trying to get as much information out of your computer as they can. And surprisingly, there's a wealth of information that they can extract if you don't ship mitigations. So they can read the screen size of your browser. They can read your desktop screen size, actually. Then they can read plugins you have installed. They can extract the version information of your plugins you have installed, and they can you can enumerate the MIME types you have in your computers, and all are a bunch of things.
Fonts. Fonts.
Yeah, fonts, exactly. Fonts are really, yeah, with fonts you can really track users good, you get a lot of entropy. Yeah, a bunch of these patches we ship are against these kind of fingerprinting needs, because fingerprinting is dangerous as the name says. It's giving you a fingerprint, and which means you can get recognized on different websites which are running these scripts. So then Tor browser is shipping the Tor client software as well. And we are shipping HTTPS everywhere to make it hard for parties to snoop on your traffic. For instance, there are malicious exit nodes in the network, or there are nodes in the Tor network where nobody really knows what are they doing, who knows. And that's why we ship actually HTTPS everywhere, to make sure we get as much TLS as we can get. And then we ship a no script where you can disable your handle JavaScript and other things you might want to get rid of. And we ship a wizard helping you get this going. So this is our solution to this problem. So the next problem is, or the first one you have to have an answer to, where do you get it from actually? So we have obviously a website, and it's www.torproject.org. And then when you surf to this one, for those who want to have this hands-on session, they can do this right now. Then you create with this website, having this big purple download button with the onion, and it's served over HTTPS. Then, if you're clicking on this link, on this download button, you're going to a download easy page. And so there are 3 things to be worth mentioning. If you, for some reason, I mean, there's this page is trying to estimate which kind of operating system you have, looking at the user agent you send. So if you're sending a Windows user agent, you get this one shown. Maybe you want to have a Tor browser for Windows, but you can still easily switch to the Mac section or the Linux section. Then you have the option here to specify a language you want to have, English being the default one. And an important thing not to miss is you can have a direct link to the digital signature of the bundle you are supposed to download. So, now it's coming actually the hard part. How are you verifying that you really got the one you wanted to have? So, and I'm actually cheating here, right? So I'm cheating actually for a purpose. I originally planned that there are at least some Windows forks or some OS X forks here, and that's why I said, okay, let's go with the just verifying the hash sums of the bundles, because I actually built these bundles and I signed them. So if you're comparing the hash sums of the things you download now, you can really be sure that it's really the bundles you want to get. So how do we do this? So on Linux, this is pretty easy. There's a tool called SHA-256sum, which is calculating the hash sum for you. These hash sums, the hash functions, are actually means of giving you a fingerprint of these things you want to hash, like the Tor browser bundle you should just download. And they're supposed to be good in a way that it's hard to give you the same hash with, for a different Tor browser bundle. So let's suppose you downloaded the 64-bit Linux version. And then you're just running this command and OS X and Windows. It's basically the same. It's maybe Windows people and OS X people are not used to this, but there are tools shipped with them. You can execute on the command line, which is in a way good because you don't have to download a different application, which gives you in turn the question: how do you know that the different application to verify the bundle is really the application you want to have, and not a modified one or a tampered with one? So how do these hash sums look like? They look fancy actually. So, and the tricky part is you have to make sure that every digit and every letter is really the one on your computer that you're seeing here. It doesn't help if you just take like the first 10 or the first 5 or something like this, because that can be easily created, giving you a modified Tor bundle. So what you need, as I said, is executing this command here and then making sure that every digit and every letter is the same as you see here. And if you're doing this right now, you're noticing this is quite tedious and quite error prone, right? But there has to be a better way. And the better way is taking the signature you probably right now have downloaded as well, as I hinted in the previous slides, and then using a tool called PGP or GNU-PG, and which is trying to deal with these detached signatures, the ASC files. And as we have a bunch of users on Linux here, I printed these fancy command line invocations. What are these doing? They are actually fetching this key, which is part of the key, fingerprint of this key, from a key server. And this key is our signing key of these bundles. And it is fetching this key and is integrating it in your local keyring. And then with this command line invocation, you are actually making sure that that this signature fits to the bundle. You download it, and you should see it's a good signature thing. But still, I mean, this one is better than just some random hash things you go download somewhere. But still, there's more to it. I mean, if you are not on Linux, there's one thing more to it is, if you're not on Linux, you need a different tool for this kind of operation, which, as I said, gives you the problem, where do you get this tool from? And if you're getting this tool, how can you be sure that this tool is really the one you want to get and not a modified one, who's pretending to be just the tool you get? On OS X, that's pretty easy. There's a download website where you can, which is HTTPS secured, and then you can get these GPG tool for OS X. For Windows, there's a tool called GPT for Win, which is unfortunately only probably available over HTTP because the website certificate is not properly.
I think Fernand just said that he's fixing that.
That's really cool because
it's
for years it's an issue that you're not able to get the GPT for Win because you're getting a certificate warning in the browser.
That should be fixed very soon from what
That's
you said.
cool. So below here is a link which is talking about these issues in depth. You can find more information about verifying signatures. You can even find information about advanced verification means. I mean, if it's not fancy enough for you, this one, and we have an even fancier one. We have, since a while, reproducible builds, meaning your Tor browser, you can build the Tor browser yourself, and you're guaranteed that you're getting a bit for bit identical Tor browser. This verification, this means of verification is even superior to this one because there's no single point of failure anymore. Like people trying to steal the private signing key. This scenario is not an issue anymore. Not so much an issue anymore if you have multiple people building the Tor browser, getting a bit by bit identical Tor browser, and every one of these people are signing it, and the adversary has to get hold of n signing keys instead of compromising one. So let's suppose you have downloaded by now and verified all the things. How do you install these? Let's skip the Windows one. We don't want Windows. We don't want OS X. On Linux it's pretty easy. If you're on a terminal, then you're just extracting the archive. Or you can right-click on your file manager and extract the bundle there. So there's both means. If you're more the terminal guy, then you're taking the first one. If you're used to a graphical interface, then the second one. So how do you get started? It's just changing to the path where your extracted browser is. Usually this one, and then you can start on the terminal again. This browser by this means, and then if you want to have a graphical user interface, then you just go into the folder and then click on the Tor browser setup. And the advantage of this one is once you started this, you can drag this icon around and attach it to your taskbar or whatever, and then every time you want to start it, just click on this icon and don't have to use the command line or terminal at all. I thought about showing this, but I realized for some reason my terminal is not seen here.
Can you drag it to the right? If you drag it off the right side of the screen, maybe.
Aha! Okay, thanks for that. So it's actually cool because the network is messing with the Tor traffic, and we can show that we can circumvent this. Okay, let's see. So if here, let's suppose I've downloaded this. And so let's suppose I've downloaded this bundle here. And
Maybe a little bit further.
oh yeah, missing something. Let me see. So tar. Okay, let's doing things. And then what I can do, let me see, giving you the overview of the, it's a terminal, but I wanted to show you the, so where am I here? Stuff is good. Talk. Okay, so then you're here. You have the setup button, and then you can just double click it, the quick screen. Yeah, then the wizard is coming. It's popping up, and then if you are just basically doing this, and then you can move these icons where you want to have. Where am I now? I see, the icon got moved to my desktop, but the desktop is invisible. That's bad. Let's do it again. Wow. It's getting rid of it. I can show the extract in this. Sorry, I'm not used to the user interface graphical. I'm more the command line. Yeah, so I can extract it here. This one. Setup. Okay, let's see if I can move it somewhere else. Sorry, I started it twice. It's complaining. Where could I move this one? I think I don't move it. But you can do attach it to a taskbar and just make it one click to get started again. Okay. This one again. So, okay, this is this one, then we don't want to have a Mac. Now you're here. And the usual thing you have to do is just clicking on the connect button. It's actually the tool launcher wizard helping you to figure things with the connection out. We can see what is happening on this network here. Let me put some debugging things here, and we can see what is going on. So, you still don't see the. Here we go. And then you're saying connect. And then it's trying to connect the network, and it's failing because there's some messing going on with the SSL things to want to use, and nothing is actually happening. So you have to be inventive actually.
Does that mean that this university is deliberately blocking Tor connection?
I don't know. I haven't looked at the traffic in detail, but it's messing with the traffic somehow for some reason. And but we have a configure button here, right? So then you're getting another feature of Tor, which is heavily used, for instance, by users in China or Iran, who are trying to avoid censorship and interfering networks. So you're basically saying, yes, I want to do this. And then you're going to the next page. And then you're having one of those type of so-called bridges, which are not publicly listed Tor relays. And you have different kind of graphical transports, which are trying to obfuscate the fact that you're actually using Tor. It's a kind of part of the arms race, right? First, the people try to block Tor, just blacklisted the IPs of the public relays or the directory authorities who are distributing the relays to the clients. And then there were bridges, normal bridges, like normal relays not listed in the public directory of relays. And people could download the information for these bridges and put them in their path, and they would actually be able to connect to the internet. But then people, for instance, China was able to enumerate all those bridges and block them as well. So this is kind of arms race going on. And there's Office proxy, this is called this protocol, is trying to avoid this issue. So you're clicking to next, and then you don't need a local proxy because you're not on a company network, and you're saying connect, and then it's going to happen. And ta-ta, here we are. So that's the thing you're supposed to see if you started Tor browser. It's saying, well, congratulations, and browser's configured to use Tor, and then you can start browsing the web. So, where are we now? I think I'm basically done with the presentation with the hands-on parts, which went actually along talking about the things. So, yeah, this is a quick screen you want to have. Then you have the option to adjust your security level. I mean, we are shipping the Tor browser with the default configuration where JavaScript is allowed, which is seen by this no script sign here. And if you say, well, I don't want to have JavaScript, it's really scary, then you can just click on the open security settings. Maybe we can show this. And then you can. Where's my You're clicking on the. You're clicking on the button here, and then there's something popping up, and then you're seeing all the privacy settings we have, and then you're seeing the security level you have. The default one is called low. It's the default one. And then, if you're not satisfied with these settings, then you can. It's basically the most, as it says, the most usable experience, not disabling things. Then you can say, since you want to have high, you can see first what it's going to happen. JavaScript is disabled by default on all sites. Then SVG images are disabled, because SVG is one part of the browser which has historically seen a huge part of memory corruption bugs, making it easier to exploit your browser. And then there are fonts. Fonts on website provided fonts are blocked for reasons. Font rendering things are blocked, and yeah, there's a bunch of things. Then HTML5 media is coming click to play, so you have to allow it explicitly before you're seeing a video on YouTube, for instance. So I suppose that's okay for you. So then you're seeing that it's scripts are not allowed anymore. Then you can use this. Okay, so that's basically the things I want to say. Let me see how we get the presentation back. Yeah. All right, thanks. Time for questions, I think. So, yeah.
So how does the DNS works with those onions links, onion domains?
You mean .onion domains?
Yeah.
Okay. So Tor has a feature on. It's called. Nowadays it's called onion services. Formerly it was called hidden services, which are basically which are services provided internally in the Tor network. So if you are hitting some of these onion domains, then and you're serving to them, maybe looking at some Federalist Papers or something, then you're not leaving the Tor network anymore. You're just being in the Tor network, and these .onion domains are they are looked up internally. There's a part of the identity key of the relay is part of the domain name of the .onion domain, which is why. Show this one here. No, I don't show this. And there are these are looking like random strings, and it's part of the public key of the relay, which is a gobbled string in front of the .onion. So these are resolved internally of Tor. So there's no external DNS resolver or something like this, which is possible with this one. Yeah. Next question.
Yeah, I was wondering, I didn't get it. What's your role in the Tor project?
So I'm currently I'm working mostly with the Tor browser, and I'm mostly working on reproducible builds. I'm maintaining this mechanism that we are getting bit by bit identical builds for every version we are building. Hmm?
You talk about verifying that you have correct installation. After a while, when you updated your Tor browser bundle, is there any way to actually verify that your installation is still correct?
So the things I showed you here, the good thing is nowadays you only have to do this once. Once you are having the hassle behind you that you have to verify the signatures and fingerprints and whatever, you're getting the updates by an auto updater, which is basically the Firefox updater modified to solve new bundles from our domains, not from Mozilla domains. And these files are signed with keys, which are baked into the Tor browser. So every time we are releasing a Tor browser update, we have to sign these so-called MOR files, Mozilla Archive, the Mozilla specific update file format. And we have to sign these MOR files, and the Tor browser is only accepting the updates if they are signed with the proper key. So there's, I mean, it's pretty hard to break this mechanism. I mean, it's not impossible, probably, but
I was more thinking about checking that there's something corrupted or something malicious has changed them on computer.
so the modifiers are built reproducible as well. So you're seeing actually the hash sums of these files, and then the central file is signed by different people who build them. And then you have a trust path that your moth file is not corrupted, and then you can take, if you're really so paranoid, you can take the moth file down and apply it manually to your browser. The browser is only accepting this moth file if it's properly signed in addition. Yeah.
So I'm kind of concerned about the installation process that you demonstrated as a barrier to people adopting Tor browser. I know that's something that the project has thought about for a while. Just thinking about Let's Encrypt, which I just described, we found that manual processes having to do with software installation or cryptography often acted as a real deterrent to people because they weren't very familiar with this, or they weren't used to doing this for other software that they use, or it took them a while, or they didn't understand the purpose of some of the steps. And I'm kind of concerned that people might say, oh, Tor is great and it gives me privacy and I really want it, but this is a lot of effort, they might say, if they're not accustomed to these things, to get it. So I guess I'm wondering about the possibility, and I really appreciate the auto updater, because that obviously made this a lot more convenient and safer for a lot of people to not have to do this over and over. But I'm wondering about steps toward maybe not having to do this at all for the greatest possible number of people, like having Tor be part of their operating system or part of some software distribution mechanism that they already have. I mean, I think, people understand that maybe people who want to spy on you might try to tamper with your Tor, so it's pretty important to have like reproducible builds. But can you do something so that most people can get Tor safely without doing manual verification?
So there's, I think for Linux there's some hope. There's currently a package called Tor Browser Launcher, which is maintained by...
Like a leak?
Exactly. So this is part of Debian and Ubuntu. And you can download this package or install this package, and then it's helping you. It's basically doing all those verification checks in the background, and then giving you the Tor browser you want to have. And this is pretty good. I mean, there are people who try to convince the Debian folks to get Tor browser as we have it in the archive in order to avoid exactly this problem. There may be one day where they just can make things like apt-get install Tor browser, and it's getting the Tor browser we have currently. The issue is that there's already things like Iceweasel and the Debian archive, and the Debian folks don't like duplicating things in the archive, doing basically the same. So we have to find ways to convince them that somehow the Tor browser can coexist with the Iceweasel they ship. But it's tricky, so this is an ongoing process, and for years now. But I still have hope that someday you'll get a Tor browser in Debian and all those derivatives. On OS X and Windows, I don't know. It's even trickier. But it's, yeah, if we had this kind of automatic mechanism to get Tor browser for the first time, that would be pretty cool.
Since it's based on Firefox, does it mess with like .mozilla directory, home folder in any way? Is there any interaction between
No, the Tor browser you download is self-contained. You can put it on your USB device, or you can put it somewhere else, and it's making sure that it's only using things in this directory. So it's not messing with your normal Iceweasel profiles or Firefox profiles somewhere else. Yeah. It's a self-contained thing. So yeah.
But you can find the profile data in the self-contained directory, which is unpacked, which is good to know, in case you want to copy it from a USB stick to another place.
Yeah, the profile we ship actually is buried somewhere deep inside the package, but it's, yeah, of course it's available. So, yeah.
Yeah, just a question about the fingerprinting avoidance. Is the scheme to sort of block the information or to mimic generic information?
So, see, the easy solution to this fingerprinting problem is just clock all those features, right? I mean, if you're not allowing websites to extract your screen dimensions or your window resolution or your fonts or your plugin state, then they are probably not be able to track you. If the information is not available, no issue. The huge downside with this approach is that you're basically breaking the web as it works. And the downside of doing this is that your users are going somewhere else. And the downside of this is that you yourself are losing cover traffic or are losing forks in the same anonymity set, giving you back actually the anonymity. I mean, if you are alone in your Tor network, then you're not getting anonymity at all because it's just you using Tor. Those, the anonymity properties are tightly connected to the usability properties, which is actually quite revealing. It's not obvious in the first instance, but it's true. So what we are doing is we're trying to mitigate this fingerprinting by still allowing these features, but making them useless for folks. For instance, if you're starting up Tor browser, then your screen size is, or your window resolution is rendered to a multiple of 200 in the width and 100 in the height, so that you're making sure that you're in one of the buckets of the where other people are too. And depending on your real screen resolution, your window gets resized in the first start to be sure that you are in one of the buckets like 1000 in width and 600 pixels in the height, depending on what you actually have. So there are maybe other forks in this bucket too, so it doesn't matter so much. But still, there is ways for website scripts to find this out because it might be useful for them. Displaying websites in a certain way because this kind of screen resolution. This is one example how we're doing this. So we're not disabling these features, but we are trying to makes them really not useful for people with fingerprinting. Yeah. So, other questions?
Well, if there are no more questions, it's about time to close this session. So, thank you, Georg.